Now let's talk about one more area of electrical vehicle where diagnostics is very important. It is diagnostics in power distribution units. Now diagnostics in power distribution units, acronymed famously PDU, including high voltage, low voltage fuses, relays and contactors, and bus bars is crucial for safe, reliable, and fault tolerant operation of electrical vehicles. Now these components manage the flow of electric power between battery, inverter, onboard charger, DC-DC converter, and other subsystems. Now faults in PDU can lead to loss of power, fire hazards, or safety critical failures. Now to answer the question why diagnostics in power distribution units is so important, this is the reason. PDU, a fault in PDU can lead to loss of power, fire hazards, or safety critical units. Now, what is meant by power distribution unit? In EV, in electric vehicles, the power distribution unit, also referred as junction box, is responsible for routing the power from the high voltage battery to various loads and protecting circuits with fuses and contactors. Also, it provides uh, insulation and voltage sensing. It enables diagnostics and fault reporting. And power distribution units can be centralized or distributed and are monitored via CAN or LIN through dedicated power distribution control module, which is acronymed PDCM, or integrated into VCUs or BMS. Okay, now coming to the diagnostic objectives. The first objective is a fault detection. The purpose is detect short circuits, overloads, open circuits. Now coming to the system isolation, you can safely disconnect in case of faults. All right, this is extremely important. This is an extremely important backup action. So in case of system isolation, you can easily disconnect disconnect in case of faults. So next is state monitoring. Monitor contact state, fuse health, current flow. Now coming to the safety compliance, ensure compliance with ISO 26262 and also ISO 6469, etc. All right. So these are the standards that must be compliant about. Now coming to the serviceability, it provides VTC and logs for post-failure analysis. All right. Now when it comes to key diagnostic elements in power distribution unit, the first element is contactor and relay diagnostics. Contactor and relay diagnostics. Okay, let's see further. High voltage contactors or relays are used to disconnect the high voltage battery for the system. Okay, first area is contactor weld detection. The symptom is contactor remains closed when commanded to open, and method is measure current when contactor is off, and consequence safe risk potential thermal event. All right. B. Next is within the contactor and relay diagnostics. Next important area is contactor bounce or open circuit detection. And what is the symptom? Voltage drop, arcing, delayed activation. And next is voltage or current mismatch with commanded state. Okay, so these are the two areas in the contactor bounce or open circuit detection. Now when it comes to feedback line monitoring, using auxiliary contacts or position sensors to validate the mechanical state. And when it comes to the next area, contactor coil diagnostics detect the overcurrent, open coil, or short to ground battery. All right. Now next important area is fuse diagnostics, both high voltage and low voltage. Modern EVs use smart fuses with embedded sensing or virtual fuse diagnostics via software. Now, A, what is the first area of detection? Blown fuse detection. Voltage on the load side 0 volt while sourcing side is live and detected via ADC channel or voltage sensing internal circuits. Now next coming is pre-fuse failure detection. Monitor fuse temperature, predict overload patterns via current history. Okay. Now next is virtual fuse algorithm. Software models expected current versus actual and flipped fuse degradation via failure. Okay, so all these virtual fuse algorithm, pre-fuse failure detection, blown fuse detection, all fall under the category, fall under the purview of fuse diagnostics. Now, when it comes to thermal and overload monitoring, using NTC and PTC sensors for thermal monitoring at bus bars and contact terminals. Next is detecting overheating due to contact resistance or high current. Next is trigger derating, cooling and shutdown. So within this thermal and overload monitoring, these are the three faulty areas that need to be monitored. Now when it comes to current and voltage diagnostics, Hall effect or shunt based sensors monitor each output line. Okay, and when it comes to diagnostics, it includes the current leakage detection, it includes the open line detection, and it includes the mismatch between commanded and actual current. For example, 20 ampere to inverter measured 0 ampere faulty contactor or open line. All right. And coming to the isolation monitoring, ensures galvanic isolation between HV and chassis ground. Isolation resistance monitored continuously as per ISO 6469693. And what are the various faults that have detected, whether it is the absorption of moisture or HV line short to chassis. Sometimes high voltage lines get shorted to chassis and contaminated connectors, and isolation faults are critical for safety interlocks, emergency disconnect. Okay, so these are the isolation monitoring. Now coming to state and fault reporting, PDU typically reports DTCs via ISO 14229 such as P0A6, which is an isolation fault, P0A94 DC-DC performance fault, and P1A10 contactor stuck closed. All right. So these are the DTCs that are part of this area. Now, when it comes to status bits, contactor open close state, fuse health, load status. All right. So these are the status bits. Now let's see some of the fault scenarios. We will see the fault, the cause, and the diagnostic indicator. Okay. First fault is at the contactor weld, which the cause is excessive arcing or mechanical jam, and diagnostic indicator is current present when the open. So the fault is current present even when the contactor is open. Now next is blown fuse. Next fault is blown fuse, and the cause is short circuit in inverter or OBC. No voltage or load terminal. Okay. Now when it comes to insulation for isolation fault, coolant leak into HV system, isolation resistance is less than 500 ohm per volt, and bus bar overheat, loose connections, corrosions, and the diagnostic indicator is temperature and threshold. Okay, now when it comes to pre-charge failure, this is a very common fault, and the cause is faulty pre-charge resistor or contactor. And when it comes to diagnostic indicator, the HV fails to rise during ignition. Okay, so high voltage fails to rise during the ignition, and that leads to the absence of ignition. Now coming to the what are the various diagnostic techniques that are used in this area. The first is pre-drive self-test. It checks the contactor actuation, fuse integrity, real-time monitoring, current voltage, temperature under load, redundant sensing, voltage comparison from multiple points, oscillographing. This is a commonly used diagnostic technique. Oscillographing, it is used in development to detect the contactor bounce. And when it comes to fault detection testing, it simulates stuck relays, open lines on HIL. So these are the various types of diagnostic techniques, and on the right side of this table you can see the purpose for which diagnostic technique is apparently used. All right. So coming to the functional safety and cyber security, ASIL D and C and D level requirements for high voltage contactor state monitoring. Because I hope you understand why D level has come into the picture, because this is a very vital functionality, and the failure at this functionality can lead to fatality also. That's the reason D level is included. Now, when it comes to fail-safe response, limp mode, shutdown, or detection, and when it comes to secure diagnostics, access levels to clear DTCs or reset relays. Now, communication protection, it includes the secure CAN or diagnostic on internet protocol. Okay, now coming to the tools and interfaces, CAN, LIN or SPI interfaces to communicate with PDUs, microcontroller. Again, another important tool is Vector Cano, ETA Sync for trace and diagnostics. ETA Sync can also be used for calibration also. And coming to EBD2 or UDS diagnostic tools, these are very important tools for the onboard diagnostic scanning, and thermal imaging or high voltage probe for manual validation. Okay, now coming to the summary table. Summary table means we are talking about the diagnostic category, the target component, and typical faults. First is the contactor state. Target component is main HV contactor, welded, open, and bouncing. Now, when it comes to fuse health, high voltage, low voltage fuses, blown fuse, thermal overload. Now, when it comes to voltage, current, load lines, open line, overload, and leakage. Next comes the isolation. HV bus to the chassis is the target component, and the typical faults detected are short moisture ingress. Now, next is thermal, which includes targets like bus bars and relays, and typical faults detected are overheat, hotspot detection. Okay, so hope all of you got a clear-cut idea about the diagnostics in high voltage components.